Imagine a world where lead melts like butter, where acid rain never reaches the ground because it evaporates in mid-air, and where the atmospheric pressure would crush a human body in seconds. This isn't science fiction, this is Venus, Earth's twin sister turned into the solar system's most beautiful nightmare. For centuries, Venus has captivated humanity with her brilliant beauty. Named after the Roman goddess of love, she's the brightest object in our night sky after the moon. Ancient civilizations called her the morning star, the evening star, never realizing they were looking at the same celestial body that would later reveal itself as nature's most perfect example of a runaway apocalypse. But here's what makes Venus truly terrifying. She wasn't always this way. Scientists believe Venus once had oceans. She once had a chance at life. So what went so catastrophically wrong that it transformed a potentially habitable world into a literal hell? Standing on Venus today, if you could somehow survive the journey, you'd find yourself in an environment more hostile than the deepest ocean trench, more crushing than the highest mountain peak, and hotter than most pizza ovens. The very air would kill you instantly, not just from the heat, but from the toxic cocktail of gases that make up her atmosphere. This is the story of planetary death. This is the story of how Earth's twin became Earth's nightmare. This is Venus beautiful, brilliant, and utterly, completely hellish. Step onto Venus, and the first thing that would kill you isn't the heat, it is the weight of the sky itself. Imagine diving to the bottom of the deepest ocean trench on Earth. The pressure at 1,000 meters below sea level is crushing, enough to implode a submarine. Now imagine that pressure, but instead of water, it's a thick, toxic atmosphere pressing down on every inch of your body. That's Venus. The atmospheric pressure on Venus is 90 times greater than Earth's. To put this in perspective, if Earth's atmosphere feels like wearing a light sweater, Venus's atmosphere feels like being buried under a mountain of concrete. Every square inch of your body would experience nearly 1,300 pounds of pressure. Your lungs would collapse instantly. Your bones would crack. Your blood would literally boil. But here's the truly fascinating part. This crushing atmosphere is almost entirely carbon dioxide. While Earth's atmosphere is 78% nitrogen and 21% oxygen, Venus is 96.5% carbon dioxide. It's like being inside a planet-sized carbonated drink that's gone terribly, catastrophically wrong. This CO2 blanket is so thick that it bends light. Standing on Venus, you wouldn't see a clear horizon. Everything would appear curved and distorted, like looking through the bottom of a thick glass bottle. The sky would glow with an eerie orange light, filtered through hundreds of miles of dense gas. And that's just the beginning of Venus's atmospheric nightmares. Above your head, if you could somehow survive Venus's surface, stretches one of the most corrosive environments in the solar system. The clouds of Venus aren't made of water vapor like Earth's puffy white cumulus formations. They're made of concentrated sulfuric acid. Sulfuric acid, the same chemical that can dissolve metal, burn through skin, and corrode almost any material it touches. On Venus, this acid forms clouds 30 to 40 miles above the surface, created when sulfur compounds react with trace amounts of water vapor in the atmosphere. These acid clouds are so dense they completely shroud the planet. From space, Venus appears as a brilliant white ball because these clouds reflect sunlight so efficiently. But this beautiful exterior hides a chemical hell within. The truly bizarre part: it rains sulfuric acid on Venus, but that rain never reaches the ground. The surface is so hot that the acid droplets evaporate while falling through the thick atmosphere, creating a perpetual cycle of atmospheric recycling that would make Dante's Inferno seem like a pleasant vacation spot. Imagine acid rain so corrosive it could strip paint from metal, falling through an atmosphere so hot that the rain burns away before it can even touch the ground. This is the daily weather forecast on Venus every day, for millions of years. But the clouds hold another secret. They rotate around the planet much faster than Venus itself rotates. While Venus takes 243 Earth days to spin once on its axis, these acid clouds circle the entire planet in just 4 days, creating hurricane force winds in the upper atmosphere that dwarf any storm Earth has ever seen. Now let's talk about the heat, the kind of heat that makes Venus the hottest place in the solar system, even hotter than Mercury, despite being twice as far from the Sun. At 460 C or 867 F, Venus's surface temperature is hot enough to melt lead, zinc and tin. It's hot enough to make aluminum glow red hot. It's so hot that electronic equipment fails within minutes, which is why every spacecraft that has ever landed on Venus has died quickly, succumbing to the planet's thermal assault. But here's what makes this heat truly terrifying. It's the same temperature everywhere. Day or night, equator or poles, the crushing heat never varies by more than a few degrees. While Earth experiences dramatic temperature variations from Arctic cold to desert heat, Venus is uniformly relentlessly hot. This uniform heat is the result of what scientists call a runaway greenhouse effect. Earth experiences a gentle greenhouse effect that keeps our planet warm enough for life. But on Venus, this natural process has gone completely out of control. The thick CO2 atmosphere acts like a massive blanket, trapping heat from the sun. Infrared radiation that would normally escape back to space gets absorbed and re-radiated by the atmosphere, creating a feedback loop of ever-increasing temperatures. It's like wrapping the entire planet in the world's most effective insulation. The surface of Venus receives only about 2% of the sunlight that reaches Earth's surface. The thick atmosphere blocks most of it. Yet it's still hot enough to melt metal. This is the power of the greenhouse effect gone mad, turning a planet into a giant oven that can never cool down. Water, the essence of life as we know it, cannot exist in liquid from anywhere on Venus. The combination of crushing pressure and extreme heat ensures that any water would instantly vaporize into steam. But Venus wasn't always waterless. Scientists believe that billions of years ago, Venus may have had vast oceans, just like early Earth. Imagine Venus as she once was. Blue skies, flowing rivers, perhaps even the potential for life. What happened to transform this potentially habitable world into the desert furnace we see today? The story of Venus's water is a story of planetary murder by greenhouse effect. As the young sun grew brighter over billions of years, Venus received more and more heat. Unlike Earth, which had mechanisms to regulate its temperature, Venus entered a catastrophic spiral. As temperatures rose, more water evaporated into the atmosphere. Water vapor is itself a greenhouse gas, so this added even more warming. More warming meant more evaporation, which meant more warming, a deadly feedback loop that couldn't be stopped. Eventually, the upper atmosphere became so hot that water molecules broke apart. The hydrogen escaped to space, while the oxygen combined with other elements on the surface. Venus was literally bleeding its water away, one molecule at a time, into the cosmic void. Today, the amount of water vapor in Venus's entire atmosphere would create a global ocean only about 1 inch deep if it could somehow condense on the surface. Earth's oceans, by comparison, average about 2.3 miles deep. Venus has lost almost all of its water, evaporated, dissociated, and lost forever to space. This is what planetary death by greenhouse effect looks like, the slow strangulation of an entire world's capacity to support life. Venus rotates backwards. While most planets spin in the same direction they orbit the Sun, Venus spins in the opposite direction, what scientists call retrograde rotation. If you could somehow survive on Venus and watch the Sun rise, it would rise in the west and set in the east. But here is the truly alien part. A day on Venus lasts longer than a year on Venus. The planet takes 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun once. This means that if you could mark Venus's calendar, you'd celebrate a new year before you'd celebrate a new day. This backward, incredibly slow rotation contributes to Venus's hellish conditions. Earth's 24-hour rotation helps distribute heat around the planet, creating temperature differences that drive weather patterns and atmospheric circulation. Venus's sluggish spin means no such relief. The heat just builds and builds, creating a thermal equilibrium of death. The slow rotation also means Venus has no significant magnetic field. Earth's magnetic field, generated by our planet's spinning molten core, protects us from harmful solar radiation. Venus, spinning so slowly, can't generate this protective shield. Solar wind strips away parts of the upper atmosphere, and deadly radiation bombards the surface unimpeded. Standing on Venus, if you could, you'd experience one of the most alien day-night cycles imaginable. A single day would stretch on for months, with the sun moving imperceptibly across the acid-clouded sky. But it wouldn't matter, because the thick atmosphere diffuses sunlight so completely that the surface exists in a perpetual orange twilight, neither true day nor true night. This is a world where time itself seems broken, where the normal rhythms that govern planetary life have been twisted into something unrecognizable. Beneath Venus's crushing atmosphere lies a landscape forged in volcanic fire. Venus is one of the most volcanically active worlds in the solar system, with over 1,600 major volcanoes dotting its surface more than any other planet. But these aren't just any volcanoes. Some of Venus's volcanic mountains tower 5 miles above the surrounding plains. Mount Mons, the highest volcano on Venus, rises 5.5 miles above the mean surface level, nearly as tall as Mount Everest, but sitting on a world where the sea level is already a hellish furnace. The volcanic activity on Venus is driven by intense heat trapped within the planet. Unlike Earth, where plate tectonics help release internal heat through spreading ocean floors and subduction zones, Venus has no such release valve. The heat builds up until it breaks through the crust in massive volcanic eruptions. These eruptions don't just produce lava flows, they release enormous quantities of sulfur compounds into the atmosphere, feeding the acid rain cycle that makes Venus's sky so toxic. Every major eruption adds more sulfur to the atmosphere, making the planet progressively more corrosive and hostile. The lava flows on Venus stretch for hundreds of miles, creating vast plains of solidified rock that have been mapped by radar from orbiting spacecraft. These flows are so extensive they have resurfaced most of the planet within the last 500 million years, relatively recent in geological terms. But here's the truly terrifying part. These volcanoes may still be active. Recent observations suggest that some of Venus's peaks may still be erupting, adding fresh doses of toxic gases to an already poisonous atmosphere. Venus isn't just a dead hellscape, it's an active, ongoing volcanic nightmare that continues to make itself more hostile to life. What makes Venus's hellish nature even more tragic is how close it came to being like Earth. Venus is often called Earth's twin because of their similar size and mass. Venus is only slightly smaller than Earth, about 95% of Earth-E's diameter and 82% of Earth-E's mass in the cosmic lottery of planetary formation. Venus got almost the same starting materials as Earth, but there's one crucial difference that's sealed. Venus's fate, distance from the Sun. Venus orbits about 25% closer to the Sun than Earth does. That seemingly small difference, just 18 million miles, made all the difference between a living world and a dead one. This proximity put Venus just inside what scientists call the habitable zone, the region around the star where liquid water can exist on a planet's surface. While Earth sits comfortably in the middle of this zone, Venus is on the hot inner edge, right at the boundary where the greenhouse effect can spiral out of control. But distance alone doesn't explain Venus's fate. Mars is farther from the Sun than Earth, yet it became a frozen desert rather than a tropical paradise. The real killer was the combination of solar distance and atmospheric composition. Earth had several lucky breaks that Venus didn't. Our strong magnetic field protects our atmosphere from solar wind erosion. Our plate tectonics help regulate atmospheric CO2 by recycling carbon through rock formation. Our large moon stabilizes our rotation and helps drive atmospheric circulation. Venus had none of these advantages. No magnetic field, no plate tectonics, no large moon, just enough heat from the Sun to trigger a runaway greenhouse effect, and no natural mechanisms to stop it. It is a sobering reminder of how fragile habitability really is and how thin the line is between a living world and a hellish wasteland. Venus serves as a stark warning about what can happen when greenhouse effects run amok. While Earth's current climate change is happening much faster than Venus's ancient transformation, the underlying physics are disturbingly similar. Venus serves as a stark warning about what can happen when greenhouse effects run amok. While Earth's current climate change is happening much faster than Venus's ancient transformation, the underlying physics are disturbingly similar. Scientists study Venus not just out of curiosity, but out of necessity. Venus shows us the ultimate endpoint of unchecked greenhouse warming. It's a real-world laboratory for understanding how atmospheric chemistry, surface temperature, and planetary habitability interact in the most extreme conditions. The parallels are unsettling. Both Earth and Venus have atmospheres rich in greenhouse gases. Both receive energy from the same sun. The main difference is degree Venus has vastly more CO2 in its atmosphere than Earth, but the basic heat-trapping mechanism is identical. Venus's runaway greenhouse effect couldn't happen on Earth overnight. Our planet has too many stabilizing factors. But Venus reminds us that planetary atmospheres can reach tipping points beyond which feedback loops become unstoppable. The loss of Venus's water, the buildup of atmospheric CO2, the failure of natural regulatory systems, these processes took millions of years on Venus, but they show us what happens when a planet's climate system breaks down completely. Venus is a cautionary tale written in acid clouds and molten metal. It's a reminder that in the cosmic game of planetary evolution, there are no do-overs. Once a world crosses certain thresholds, there may be no way back. For all its hellish horror, Venus serves a crucial purpose in our understanding of planetary science. It's a natural experiment in extreme greenhouse effects, showing us the physics of atmospheric collapse on a planetary scale. Scientists study Venus not just out of curiosity, but out of necessity. Venus shows us the ultimate endpoint of unchecked greenhouse warming. It's a real-world laboratory for understanding how atmospheric chemistry, surface temperature, and planetary habitability interact in the most extreme conditions. The parallels are unsettling. Both Earth and Venus have atmospheres rich in greenhouse gases. Both receive energy from the same sun. The main difference is degree Venus has vastly more CO2 in its atmosphere than Earth, but the basic heat-trapping mechanism is identical. Venus's runaway greenhouse effect couldn't happen on Earth overnight. Our planet has too many stabilizing factors. But Venus reminds us that planetary atmospheres can reach tipping points, beyond which feedback loops become unstoppable. The loss of Venus's water, the buildup of atmospheric CO2, the failure of natural regulatory systems, these processes took millions of years on Venus. But they show us what happens when a planet's climate system breaks down completely. Venus is a cautionary tale written in acid clouds and molten metal. It's a reminder that in the cosmic game of planetary evolution, there are no do-overs. Once a world crosses certain thresholds, there may be no way back. For all its hellish horror, Venus serves a crucial purpose in our understanding of planetary science. It's a natural experiment in extreme greenhouse effects, showing us the physics of atmospheric collapse on a planetary scale. As we end our journey to hell, we return to the paradox that is Venus, the most beautiful object in our night sky, and the most hellish world we know. From Earth, Venus shines like a brilliant diamond against the velvet darkness of space. Ancient poets wrote sonnets about her beauty. Modern lovers make wishes on her light. Yet we now know that this celestial beauty masks an environment so hostile that it defies imagination. Venus challenges our human tendency to equate beauty with benevolence. Her bright, steady light has guided travelers and inspired artists for millennia, never revealing the toxic chaos that lies beneath her reflective cloud tops. She's nature's ultimate wolf in sheep's clothing, gorgeous from a distance, deadly up close. But perhaps that's Venus's greatest lesson: beauty and horror are not opposites in the cosmos. They can coexist in the same world, separated only by distance and knowledge. Venus is simultaneously the most beautiful planet in our sky and the closest thing to hell that nature has ever created. The next time you see Venus hanging in the twilight sky like a celestial jewel, remember what you now know: behind that brilliant light lies a world of crushing pressure, acid rain, and furnace heat. A world where metal melts on the surface and rain evaporates before it falls. A world that shows us both the awesome creative power of planetary formation and the terrifying destructive force of runaway climate change. Venus is beautiful. Venus is hellish. Venus is a reminder that in space, as in life, appearances can be devastatingly deceiving. And in her toxic splendor, Venus continues to shine an eternal beacon of beauty and terror, forever visible in our sky, forever unreachable in her perfect hellish isolation. Welcome to Venus, the most beautiful nightmare in the solar system.